Today I am going to explain the push-down automata concept. It comes under third unit, second part. So third unit contains two concepts. One is grammar and another one is push-down automata. So if you consider push-down automata, it is an extension of finite automata which is used to control an input tape and stack. Then it will produce an output format. Either it will accept a string or reject based upon the given input in it. So if you consider a finite automata which takes input symbol on tape, then it will process some iterations in it. Then it will go to final state whether the input is accepted by it. The same concept will be applied here, so that only we called the push-down automata is an extension of finite automata. We already know the finite automata types. It is two types, deterministic finite automata and non-deterministic finite automata. Here push-down automata can be implemented based upon a non-deterministic finite automata. So in an NFA, the epsilon NFA may be used in PDA. So here stack is used for storing the input values, which comes push and pop operations in it. Then the input for push and automata is a context-free grammar. So the context-free grammar comes under type 2 grammar. So it has a finite state control which takes input in an input tape, and this finite state control also control a stack. The stack contains input strings with initial symbols in it. With the help of a stack, a PDA can remember infinite amount of informations in an input tape. So the output of PDA is, if you give an input string, either it will accept that string or reject the string based upon a context-free language or a context-free grammar. So this is the sample function of a push-down automata. So if you consider input, the input may be given either a context-free grammar or a context-free language. So in our future videos, we will solve the problem from conversion of CFL to PDA and also conversion of CFG to PDA. So now in this class, I give the introduction about it. So if you take an input, the input may be a set of string which is derived from a context-free grammar or from a context-free language. Then stack contains some initial symbol in it. For example, I am taking initial symbol as Z in this video. So always this stack symbol will be stored as an initial symbol on take. The remaining values are sigma. That means the alphabet symbols of context-free grammar or a context-free language. So at a time, the finite state control will check the input. That input will be stored in input tape. So input tape is nothing but a temporary memory location. That means it is a buffer. So it has a consecutive memory locations in it which contains cells. So in each cell, one input symbol will be stored. So at a time, the finite state control will read only one cell at a time, and it will process some operations based upon the topmost value on stack. Then after, it will scan all the input values from an input tape. Then it will accept that string or reject it. So this is the basic operation behind a push-down automata. Then if you consider a model of PDA, PDA consists of three sets. One is a finite set of states, which will be denoted as Q. Because it also supports, it is an extension of finite automata. So set of states are represented with Q in finite automata. The same notation will be used in push-down automata. Then a finite set of input symbols which will be derived from an alphabet set sigma, and finite set of stack symbols, it will be denoted with the notation called tau. So based upon these three notations, PDA will process some function. So if you take one transition means the function. So at one transition, the finite state control of a PDA will check the symbol on tape and also the topmost value on stack. So if you consider a transition function, tilde contains three parameters. The first parameter is a set of state. Second parameter is derived from a set of alphabet symbol. And the third parameter is used to read a symbol on stack. So this is the three parameter of PDA. So this is a given input. Based upon it, it will check the value. So at a time, control head read the input symbol on tape. Then it will go to the new state. So the output is it process a current state with the current input symbol and the topmost value on stack. Based upon the input in input tape and stack, it will go to new state or it may stay in the same state. So the output first parameter is your state, that is Q. And if you consider stack has two operations, push and pop. Here three operations are available. One is push operation and another one is stop push operation. Then the third one is pop operation. So if you consider the output of a PDA, if you are using push operation, the second parameter of output contains two values in it. Suppose if you are implementing stop operation, the second parameter of that output contains only one symbol in it. If any pop operation will be done in a stack, then the second parameter of output is epsilon. That means it contains only one state, one symbol. So that only I am writing these three operations. So if you consider the output may be first one or second one or third one. First one contains always the first parameter of an output is state. So either it may be a stay in current state or it will go to new state. The second parameter only varied. Just check it. So if two symbols are available on an output, then push operation will be done. If only one symbol that is not epsilon means stop operation will be done. If only one symbol is available and that is epsilon means it check the pop operation. So this is the way we can able to do the transition functions on PDA. Then based upon the basic functionality of a push-down automata, we can able to define a push-down automata. Here finite automata contains a 5-tuple representation, but in a push-down automata, stack is used, so the notation will be extended as a 7-tuple representation. So what are the 7-tuple means? Already 5 parameters are retrieved from a finite automata. That means Q is a set of state, sigma is an alphabet symbol, tilde is a transition function, Q0 is a starting state and F is the final state. So it is already available in a finite automata. Here we know that push-down automata is an extension of finite automata. So those 5 tuples will be available here. The only difference is the tau notation and the stack symbol. So tau means the function, which is what is the function or what are the operations you are doing on stack. So that will be represented as tau. And the initial symbol, which symbol you are used to store it in a stack. So that initial symbol will be represented with a 6th parameter. So these are all the notations. And here I am giving the difference between the finite automata and push-down automata. So we already know the concepts of finite automata. The input for FA is a regular expression or a language. But if you consider PDA, the input is a context-free grammar or a language. And regular expression comes under for type 3 grammar. Context-free grammar occurs at type 2 grammar. FA is a 5-tuple representation, but PDA contains 7-tuple representation, and there is no stack is used for implementing FA, but using stack only we can able to implement a push-down automata. Then if you consider a transition function notation, finite automata contains two parameters in transition function and only one output notation. But if you go for a push-on automata, the input for transition function is three values. One is current state, current input symbol on tape, and the topmost value on stack. Two output value. The first value is the output state, and the second one is what are the operation you are doing or implementing in a stack. So this will be the introduction about push-on automata. The remaining topics about push-on automata will be discussed in next session. Thank you.